Carnotaurus was not specialized for running. But if it wasn't specialized for running, what was it actually doing? Folks casually attuned to dinosaur paleontology may recognize the abelosaurid Carnotaurus sasteri as a fast-running theropod, as it is commonly depicted in popular media. Said folks may also have watched the Skeleton Crew's presentation on how Carnotaurus was not really an animal adapted for running, and may have been thrust into a state of denial. But just because Carnotaurus wasn't the animal we commonly perceived it as, doesn't mean it wasn't a physically impressive animal. In fact, what Carnotaurus lacked in speed, it made up for in power. Let me explain. We first need to understand where Carnotaurus fits within the abelosaur family tree. Being one of the most derived abelosaurs, it's deeply nested within the clade Phyrilosauria, or stiff-backed lizards, a group characterized by several anatomical peculiarities. Their posterior neck vertebrae, for instance, barely have any articulation, with widened epipophyseal processes, reduced neural spines, and long interlocking cervical ribs, resulting in a stiff, sturdy neck that can barely form the classic S-curve seen in other theropods. Members of Phyrilosauria also exhibit stiffening of their dorsal and caudal vertebrae as well. Both series of vertebrae have accessory joints that form lock and key arrangements, increasing rigidity. Their sacral regions show high degrees of fusion, and their anterior caudal vertebrae famously have both forward and backwards projections on the transverse processes that overlap, further adding structural integrity. As a bonus, most ceratosaurs, of which abelosaurs are, have an extra sacral vertebrae compared to most non-avian theropods, with 6 instead of 5. But what's all this skeletal reinforcement without the muscle power to abuse it? While the often cited caudofemoralis longus in Carnotaurus and by extension other abelosaurs may not have been as absurdly massive as commonly believed, they still had powerful upper and lower leg muscles, courtesy of another derived abelosaur trait, a large hatchet-shaped Nemo crest on their tibia. That serves as a muscle insertion point for thigh and calf muscles, and its expansion in abelosaurs signify equally expanded musculature to generate more leverage. Returning to the neck, it was also well muscled. Those wide epipophyseal processes, along with enlarged scapula and coracoids, served as extensive muscle insertion points, making for a formidable system that can both resist and generate large forces, driving the business end of this animal, the skull. With a strong bite, laterally compressed teeth for cutting, fused skull bones, cornified skin to absorb impacts, and, lest I forget the signature horns that gave Carnotaurus its name, this was an animal adapted for frontal engagement, brute force, and using its whole head as a weapon. Sometimes it can be difficult to accept a change to our preconceived notions about something we are deeply interested in. But perhaps grounding our understanding in what the evidence really shows us can give us a deeper appreciation for what the truth entails for these animals of a bygone era. And I sound like a certain magenta-clad prosecutor with that last line.